Hello students, let's talk about the ionic bonding in today's class. So before discussing about the ionic bonding, let's just first discuss what is a bond. So basically a bond is a force of attraction between two atoms, and we have different kinds of bonds, that is the ionic bond. Then we have the covalent bond, and then we have the coordinate bonds. So in today's video we are just going to discuss about the ionic bonding. So now the term ionic bonding, also called the electrovalent bonding, is the kind of bond which is formed between the two oppositely charged ions. For example, we are talking about NaCl. So this is the kind of bond that is between the Na plus ion and the Cl minus ion, that is the oppositely charged ions. So now if I just ask you why the bond formation takes place. So whenever a bond is taking place, whenever a bond is formed between any two atoms, what is the reason behind it? So as you already know the rule of octet. The octet rule, every element wants stability. Every element wants to have stability, and for that stability it has to complete its octet, which is to have 8 electrons in its last shell. Whenever an element has its electrons, 8 electrons in its last shell, it becomes active, inactive, and it becomes inert. So in order to complete its octet rule, to become very stable, it will do the formation of bonding by any of these three methods. So now we are going to discuss about the ionic bonding. So now first thing that we keep in mind about discussing the ionic bonding is that this kind of bonding is formed between dissimilar atoms. This bonding is formed between dissimilar atoms. Now by dissimilar atoms we mean that we should be having a metal and a non-metal. Okay, so we will also see which element is considered as a metal and which element is considered as a non-metal. So the first thing that we are discussing is dissimilar atoms are present during the formation of ionic bonding. So after that we will see a metal, it will lose electron, and a non-metal is present which will gain electron. Now which element is considered as to be a metal? So basically whenever any element has 1, 2 or 3 valence electrons. For example, I talk about sodium. Its atomic number is 11. So the configuration is 281. This 1 electron is present in its valence shell. Valence shell is the outermost shell. Valence shell is the outermost shell. So basically whenever there is 1, 2 or 3 electron in this outermost shell, the element is considered to be as a metal, and whenever we have 4, 5, 6 or 7 electrons in the valence or outer shell, for example we have oxygen, we have sulfur, we have nitrogen, all these configurations, in each element's configuration we have 4, 5, 6 or 7 electrons in its valence shell. The element is said to have a non-metal, and now we already know what is a metal, which is considered to be a non-metal. Metal will lose electron and non-metal will gain electron, and by this phenomena there will be a transfer of electron. This point is very important, that transfer of electron takes place in this kind of bonding. Now we will see how this transfer is going to take place by losing and gaining of electron by a metal to a non-metal. how the ionic bonding, we have taken the very basic example for NaCl. You can already see there are conditions. We have dissimilar atoms. This is positively charged and this is negatively charged. So discussing about the type of bonding in NaCl, that is sodium chloride, we will first take the metallic part, that is sodium, and first we will write the electronic configuration for sodium. The atomic number for sodium is 11, so the configuration will be 2, 8, 1. Similarly for chlorine we have the atomic number 17 and the configuration for this will be 2, 8 and 7. Now very basic, we have to know the atomic numbers at least from 1 to 30 to write these electronic configurations. Okay, so I already know that sodium has atomic number 11 and for chlorine, so first step is to write the electronic configuration. Okay, so after writing the electronic configuration, now we have seen that we are having one electron, so this is a metal. Since it is a metal, it will lose electron. Since this valence electrons are 7 in chlorine, it will gain electron. Now the basic requirement for this compound, this Na, it wants to have octet complete. So how it can have its octet complete? By either losing this electron or just gaining 7 more electrons. Okay, there are basically two probabilities to have this 8 electrons in its valence shell. या तो हमारे पास सोडियम क्या करेगा, it will lose 1 electron or it will have to gain 7 electrons, and we know gaining 7 electrons is not possible. So sodium, since it is a metal, it will obviously lose electron, and by losing 1 electron it will get stable configuration and complete octet. So basically now in the next step we will write the Lewis diagrams. Lewis diagrams is the depicting of valence electrons. Okay, so sodium has 1 valence electrons. I have marked Na with the valence electrons. Then we have chlorine. Chlorine have 7 valence electrons. Now chlorine will gain 1 electron to complete its octet. So we will mark the Lewis symbol for chlorine. Now we can easily see that Na wants to lose 1 electron, so it will transfer its 1 electron from sodium to chlorine, and this is how the transfer of electron takes place in ionic bonding. Now after losing this 1 electron, Na will become Na plus, and chlorine by gaining this electron will become Cl minus. So basically sodium is losing 1 electron to form Na plus. Earlier sodium has configuration 281. It was not inert, so it has lost its electron to give Na plus, whose configuration is now 2,8, a very stable configuration. And chlorine has gained 1 electron to form Cl minus, and its octet is also now complete. So this is how the formation of NaCl, Na plus and Cl minus takes place by the ionic bonding. So by this process we can see how transfer of electron takes place from a metal to a non-metal to complete the octet, and this is how the ionic bond and the formation of ions takes place in the ionic bonding. We can also consider some other example. For example, MgCl2, we will follow the same steps. First we will write the configuration for magnesium, which is 282, and we will draw 2 valence electrons like this. Then we will have chlorine atoms. Again we have 7 valence electrons, so we will make the Lewis diagrams for the chlorine as well, and again we can show the transfer of electrons. Each chlorine is deprived of 1 electron, so magnesium will lose its 2 electrons to form Mg2 plus, and 1 chlorine will form Cl minus, so there will be Mg2 plus ions, and 1 chlorine is accepting 1 electron, and there are 2 such chlorines. So these will be the ions formed in this compound. By this trick you can easily draw diagrams for any of the formation of ionic compounds. Now let's just discuss some of the properties. Some of the properties for these ionic bonding is, firstly, it consists of the ions, and since it consists of ions, these are good conductors of electricity. These are very good conductors of electricity, but you have to keep one thing in mind. These are good conductors of electricity only in two medium. One is aqueous and another is molten. In aqueous or when they are molten, because whenever they are in aqueous or molten, they can easily lose their force of attraction. They have very weak force of attraction, and then only they can give these ions. Otherwise, first point we will write, ionic compounds are if anyone asks you, are ionic compounds good conductors? You can say yes, only when they are in aqueous or molten state. Whenever they are in solid state, they do not conduct electricity. So whenever they are in solid state, they are not good conductors. Since the structure in solid state is very packed, very much strong forces of attraction are there between the solid state structure of these ionic compounds. They have high force of attraction of their crystal lattice. If we talk about NaCl or MgCl2, etc. So only these ions, these forces can reduce in aqueous and molten state, and hence these are very good conductors at this state. Another point we have, they are having melting points and boiling points very high. Number 3 point, we know that these compounds are soluble in polar solvents such as water. So these are some of the properties we have to keep in mind discussing about the ionic compounds. Thank you so much.